In this video, I want to talk about what we call the inverse function. All right, and what this is leading up to, we talked about our regular function, leading up to what we call our exponential and our logarithmic functions. And in order to graph those particular functions, we need to realize that they are inverses of each other. So we need to understand what the inverse function is. And all the inverse says is that if I have a set of values or a set of inputs that we'll normally call our x, these are our inputs. We normally call these x. I can map them onto our y values, which we call our outputs out here. And these are our y values. And every x gets mapped to some y. And this is generally what we call f of x. That's how we get a function. Remember, for a function, the x values do not repeat. Well, when we talk about the inverse function, what we're talking about now is that we reverse the mapping back this way. And so we call f inverse. This little one means inverse. F inverse of x means that the output and the input are going to switch. So literally here x gets mapped to y. And that is what we call f of x. This is what we call f of x right here. In the inverse, f inverse of x, the x's are going to switch to the y's, and the y's are going to switch to the x's. So we're literally switching x and y. So as an example, let's say we have a set of points for a particular function f of x. So let's say f of x has these points. F of x has the points 3, 2, 2, 1, and 0, 1. Now, if I want to find the inverse of this function, f inverse of x, all I have to do is switch the points out. So 3, 2 would become 2, 3. 2, 1 would become 1, 2. And then 0, 1 would become 1, 0. So this is the inverse. And one of the questions we ask ourselves when we deal with any inverse is, first off, is a function invertible? What that means, for a function to be an inverse, it has to be what we call 1 to 1. It has to be 1 to 1. And what 1 to 1 means is that basically the simplest thing you can look at is that for every x, there's exactly only one y. Likewise, that for only y, there's exactly only one x. So there's one unique value for each thing. And if you think about it, you can draw it easier to see it, what I mean by that. Remember what a function is. A function is anything where the x values do not repeat. And so let's take a function such as the quadratic function, a parabola. It looks something like this. We know that this is a function because the x values aren't repeating. Remember how we test that? We can test to see if the x values don't repeat by doing a vertical line test. And on a vertical line test, what should happen is that no one line should touch any one point more than once. And here we can see that this is a function. Now, to go a step further then to see if it has an inverse, it needs to be 1 to 1. And 1 to 1 just means that no y values also repeat. So generally in a function, the y values can repeat. In an inverse function, though, the y values cannot repeat. So to test that, we do what's called the horizontal line test. And as soon as we draw a horizontal line, we see that there are 2 points sitting on this horizontal line. And through the horizontal line test, we can tell that this is not a 1 to 1 function. It's not 1 to 1. So that means the inverse, or f inverse of x, does not exist. Right? So let's look at a function that that actually has an inverse. And again, in order to tell if it has an inverse, we need to look at and see if the points are repeating first. So if I look at a function like the cubic function, for instance, the cubic function is a function. It passes the vertical line test first. It also passes the horizontal line test as well. And because it passes the horizontal line test, this is a 1 to 1 function. And that means that the f inverse of x exists.